It's a pleasure to be here. I have very good memories of the last time I spoke at the NYJavaSIG, also at Frank's invitation. I think that was about 11 years ago. I spoke about Spring on that occasion. So this time I'm quite pleased that someone from Google is talking about Spring. That kind of feels pretty good. So what I'm going to talk about today is delivery and automation, and why I think we have some pretty big problems as an industry. How many people have heard the phrase, shoemakers' children go barefoot? It's also like, doctors' wives die young. Admittedly, that one's a little bit sexist, but, the same kind of thing. Doctors' families die young. The same kind of thing where somebody who is highly skilled in a particular area doesn't actually practice that on themselves, right? Isn't actually using their core skill set closest to home. So I'm going to argue that as developers, we evidence this behavior. We do not use our core skills to solve our daily problems. So people pay us a great deal of money to automate things, right? As an industry, we're pretty well remunerated, and we do a pretty great job, right? The business comes to us, they need, they need a new website or a new, financial algorithm implemented, and we do a nice job on it. We build tests, we apply everything we've learned in school or maybe, on the job, and we engineer the best possible solution we can. But we encounter lots of problems in our daily work which are extremely painful and which we don't apply those core skills to. Let me give you some examples. We live in a world of a proliferation of services. So, for example, when we first started doing CI back 10, 15 years ago, we had a very small number of very large, complex projects, right? So you'd have a handful of, 5 million line, probably Java applications. They all had complicated builds. They were all special in their own way. And, it made sense to treat each of them specially in terms of builds. We live in a world where this is no longer the case. We have very large numbers of much smaller things. It doesn't matter whether we technically use the buzzword microservices. The fact is the entire world, all enterprises out there are gradually moving towards more finer-grained services. So suddenly, instead of having 5 million line things, we've got 1,000, 500 to 10,000 line things. And this means that our problem of delivery is getting worse. One of the things that's always motivated me in my career is trying to find the thing that sucks most for developers and trying to improve it. Back when I set out with Spring, writing enterprise Java applications was really pretty awful. Right? Remember particularly in the days of EJB2, it was pretty dire with the deployment descriptors, all the entity band stuff that never worked. Right? It was really, really horrible and nasty what you had to do to deliver a single piece of business logic. With Spring and Hibernate and related technologies, we changed that. Then also you saw the emergence of Rails, the idea of convention over configuration, and then Spring Boot in turn brought those lessons back to Java. So we saw from Ray's excellent talk, we saw just how easy it is to create Java applications today. It's also pretty easy to deploy them. As we saw, it's easy to deploy these things to GCP. We've got some really pretty cool functions in that platform, and there's also Kubernetes, Cloud Foundry. There's a bunch of good technologies out there. Back in the old days, we often were unfortunate enough to have to interact with WebSphere. It was very, very unpleasant. I have never yet met a developer who liked WebSphere. Whereas now I've actually seen, for example, in the field in the last couple of weeks talking to enterprise customers, I've seen a lot of developers who really like Cloud Foundry. The technologies that we have today for deployment are really pretty damn good. The problem is there's a gap in the middle. It's really, really easy. It's ridiculously easy to create projects with things like Spring Boot. Pretty easy to deploy them. But what happens when we have hundreds or thousands of them? How do we maintain that and ensure that we deliver it at scale? So this is what I mean by saying that our delivery problems are getting worse. Let me back up what I'm saying. How do you change the delivery flow across 1,000 services? Let's suppose your CIO gets hauled up before the board after the Equifax breach, and they say, how soon can we have black duck? And by the way, the answer should be like this week. Then, of course, your CIO comes to the teams, and you're like, okay, well, I don't know quite how long that's going to take, because each one of those projects has got a build pipeline file in it. So, we're going to have to track them all down, and it's quite a large piece of work. So, one of the things that wasn't a problem when we had a small number of highly complex builds is duplication in build pipelines. Now, it's not unusual to see organizations, enterprises with thousands of projects. Everyone has their own build pipeline in general. This is from actually one of Adam's internal projects back in the days when we didn't actually deliver that project with Adamist. This is part of the Travis YAML file. I'm not particularly picking on Travis, they're pretty representative of the way these things work. You have YAML, and it's supposedly declarative, but then you discover the 400 lines of bash that sits behind it. Does this seem familiar to people? People recognize this world? It's nasty. And if you want to go through all of your 1,000 projects to make a change like, hey, let's put sonar cube, static analysis, let's put maybe an approval gateway before deployment from staging to production, let's bring in black duck, it's really hard because of this proliferation, which is now very painful. Secondly, how you express those behaviors is also really hard. Who likes programming in YAML? I don't think anybody likes programming in YAML. I don't like doing anything in YAML. I don't like opening a YAML file. I believe YAML is one of the greatest insults to computer science ever created. YAML is an abomination. Sorry, that's So, really what you're trying to do here is program in a mixture of a horrible not programming language and program in a kind of not quite programming language with Bash. Bash is, Unix scripting is a wonderful thing, it's done many marvelous things for humanity. But the fact is we do know things about computer science that are not reflected in Bash. So we have learnt a lot about, modularity, object orientation, functional programming. We've learnt rather a lot, and those lessons aren't necessarily expressed yet. So, first problem that I think we have internalized so much that we're almost suffering Stockholm Syndrome is it's really, really hard to change delivery across many projects. How do you create new projects? This is another thing that we do really quite frequently. It's astonishing how important this is to many enterprise customers. Well, one thing you could do is you could do it by hand. So this is, it's meant to be an eye chart, you don't need to read it. So basically, find the most similar project, copy it, probably bring up an IDE and delete the things that are not quite applicable, and then go and create a Git remote and, push it up to the Git remote. It's fiddly, it's problematic because amongst other things, how do you know you got the right project, right? You're creating a new Spring Boot project. You probably went and found the one that you think is the most recent one. How do you know that's really up to date? How do you know they didn't make a mistake? Of course, you could automate it. So we already saw Spring Initializer from start.spring.io. Look, Spring Initializer is a good thing in many ways, but it also has a number of problems. One of the problems it has is it gives you a raw vanilla Spring Boot project. So you're going to have to put your own stuff in. A lot of companies solve that by forking Spring Initializer. It's surprisingly common in the enterprise. And then, of course, they can put their own stuff in the project. The problem is, firstly, that this will only help you with Spring. And, I love Spring a lot, but, you do actually sometimes need to create other projects. But secondly, it's pretty hard to maintain this. If you look at the internals of Spring Initializer, it's a mixture of Java code and templates that have got magic variables. So for example, if you fork that thing and mess with it, you don't even know that the projects you're creating are going to compile. This is not good. So it's a real disincentive to upgrading the kind of starting point for your projects. So I would argue that project creation is another really important thing that we've got used to living with suboptimal approaches for. And we really should do something better. Another example of how we're not necessarily applying what we know about engineering is how do you keep your projects up to date? Let's suppose you want to upgrade your version dependencies across a bunch of projects. Let's suppose you want to make updates to a lot of projects to introduce something. For example, I was looking at Ray's presentation and thinking, I know how I can use Atomus to, modify at scale those, app web engine or whatever files. So, how do you make changes? How do you, for example, change the scaling rules if you wanted to do that? So, the way you probably do it is you use your favourite IDE and you go and hunt down every one of those projects and you make the change by hand. Has anyone heard the analogy of cattle versus pets from the microservices world? Principally meant to apply to operating these things in the cloud. Right? When you're operating your projects, you want to be rather ruthless with them, right? Happily kill them off, get new ones, you don't form an attachment to them. I would argue that when we think about delivery, the cattle versus pets analogy is just as important. So if I'm doing this, I'm giving every single project a lot of care and affection like that cute little spaniel. What we really need to do is we need to be a bit more efficient. We need to be a bit more dispassionate and do it the way they do it with cattle. So, instead of lovingly edit every project, we really should be able to do this in a repeatable way. And, we can't easily do it. So, these are just a few of the reasons that I really think it's time to rethink delivery and think, okay, we need a fresh approach. What's missing in the world we've seen? There's not enough automation, right? It's hard to automate these things. A lot of them we just do on our local machines and no one else sees what we've done. That's bad. We should be automating a lot more. Remember I suggested that we should apply our core skills to making our own work more effective. So we're good at automating things. Why don't we automate more of what we do? Secondly, there's a missing concept when you look, for example, at the proliferation of build pipelines. And that is the idea of organisation and team policies, not just project policies. So for example, if we've got 1,000 projects, say 600 is Spring Boot, 300 are Node, and we've got a few dogs and cats. Essentially, we don't have 1,000 distinct pipelines. We should have maybe 5, right? Probably all or most of our Spring Boot projects should go through the same flow to production. They're not all needing their own distinct pipeline. We should be able to say, oh, we want to run a SonarQube analysis on all the Node projects, but on the Spring projects, maybe we'll use some other tool that we prefer. So we should be able to express that, and currently we can't really do that. Thirdly, there's a reliance on hacking, not engineering. You saw that ugly mix of YAML and Bash. That's not really engineering. That is a deeply tactical solution. It's not a strategic solution. For example, is it modular? No, it's not modular. Is it testable? No, you test it by seeing if things break when next time you make a push to your project. So all of those things that we know and love about computer science, by and large, we don't apply computer science to this. It's also, I think, time to think bigger. So traditional approaches view CD as an extension of CI, right? CI, we've got a reasonably good solution, or at least we think we have. We view CD as being something that we kind of try to push our CI tools to do, right? If the only hammer you've got is a Jenkins pipeline, you're going to do CD by having fancier and bigger Jenkins pipelines. I actually think that's wrong. I think we're thinking about CD entirely wrong if we think about it as extending out from CI. We should think of CD as a special case of a comprehensive solution to automation. And hopefully when I get into the demo, what I mean by this will become more apparent. That really you should have a solution that enables you to automate lots of things and happens to be particularly good at automating delivery, rather than just attempt to use the one little hammer to solve every problem. If you do that, you can achieve improvements in two key axes. I often think about, actually this, Ray will appreciate this, this is something I stole from Google, the SRE book, where they talk about the importance of getting from manual to automated, and even where possible, from automated to automatic. Very, very important. There's a whole bunch of things that session where you're creating, terminal session where you're creating a project, you're copying stuff, which it wasn't repeatable, it wasn't scriptable, it just sits on someone's machine. So manual is often bad. We want to automate it, and in many cases we want it to be automatic and happen all the time, the right way. But I also added another axis which I think is really important as well, and that's visibility. So, if I'm doing something just, sitting there using my terminal on my machine, it's not visible to anyone else. So if I'm really clever at it, doesn't help my teammates, heaven forbid, axes are very important. And I would suggest that most organizations are down in the left-hand corner. So, how do we solve these problems? I think one of the key things is that we need an API for software. We have APIs for lots of things. Let's look at some of the things we have APIs for. We have an API for Google. Pretty much everything that you would want to do with Google, there is an API for, and it's documented, and you can go and write code against it and do great things. Cars have APIs today. Even refrigerators have APIs. How many people watch Silicon Valley? Not always good when refrigerators have APIs. But nevertheless, it's inevitable. So a whole bunch of things in this world have APIs. Why is that good? It is generally good because if you give a developer an API, you're unleashing the creativity of that person. This is what we do as developers and technologists. Like when we have an API for something, we build amazing things on top of it that potentially the people who gave us that API don't really expect. So one of the things that we conspicuously lack an API for is software. Obviously there are certain things that have APIs, but nevertheless, you think about all those things that I showed as problems before, like changing delivery across many projects, updating code across many projects, creating new projects. These are not things that there's really an API for. So, now I'm going to get to what Animus does and why I believe it's important. So, we want to address many of these problems in a new way and hopefully do for delivery what Spring did for Java EE. So firstly, we want to replace all those build pipelines with an event hub. Remember I said there's a missing concept about what happens in your organization. The organizational policy. Something like every time something is pushed to master, it must have SonarQube and Black Duck executed against it. Something like that, that's an organizational policy that should be expressed in one place. Our solution is we have a service that listens to events from across your source control system, external build tools, deployments, issue creation, and enables you to process those events in a single place. And I'm going to get into a lot of coding shortly. Secondly, for that to work, you really need a sophisticated model of the projects and the activity around them. So you've got to have a model that enables you to get into and manipulate code, that enables you to say, oh, this push was made by someone who's on a particular team that we want to, apply more stringent security checks to their contribution. Something, all of these kind of things that you might want to express. So that really is, where what I call the API for software comes in. Thirdly, bring back the computer science. You should not write your automations in YAML and Bash. We think you should write them in code. What's more, you should write them not only in a real programming language, but with a framework that brings the kind of productivity that we saw with Spring. So with Animus, the goal is we provide the API for software, and that spans both your delivery process and your code. You write one piece of code and apply it everywhere. Sun may be gone, but I can still rip off this loading. So one question that we started to ask ourselves, what would Spring for delivery look like? How would you, build a framework to solve these kind of problems? And so with that, I'll pause with the slideware and show you a demo of what we regard as the Spring Boot of delivery. So, my demo is going to use Slack. This is something that's been giving me a lot of stress today, because I don't know if you heard, but Slack was down for quite some time this morning. But it seems to be up now. So what I'm going to do is demonstrate how Animus addresses many of the things that, many of the problems that we encounter and need more automation for. So here I'm starting up what we call a software delivery machine. So I'm starting up something that is built using this framework for delivery. This one is happening to run on my laptop, but I can run it anywhere I like. If I wanted to run it in Kubernetes or in your own data center, right, it can run anywhere. The technology, by the way, is Node, and our preferred programming language is TypeScript. So all the code I'm going to show you tonight is in TypeScript. TypeScript, by the way, I think is, it's like still reconnecting, is really fantastic. It's a very, very nice programming language. It's also, if you come from a Java background, which obviously you folk do, you'll find TypeScript surprisingly easy to pick up. Definitely easier than raw JavaScript. Okay, so with Animus we put a strong emphasis on chat ops, and we think there are a lot of benefits to this. So I'm going to start by creating a new project. So I'm going to do that by typing in a Slack command. And this is going to gather the parameters that are associated with my generator command. So name of the target repository, let's say Zappa. If I do that, I've got so many channels that will appear at the bottom. And also I actually saw on Twitter a photograph and quote from Frank Zappa today and was reminded how cool he was. So we'll call the project Zappa, and the package was Mothers of Invention, right? com.mothers. So as you can see, this is taking some of the information that you would expect from, say, a Spring Initializer. But there's a very different approach here, and we think it's a lot more powerful. So if I go to my Slack team, this is the GitHub organization associated with this organization. I am actually going to do my project creation from what we at Adams call a seed project. So our approach is very different. We don't use magic templates. We use like bog standard projects that will compile and you can use your normal tooling on. And our generation process actually does a transformation on that to get to the desired end project. So this means, for example, in your organization, you can have as many of these seed projects as you want, and you can just evolve them using your normal tool set. Furthermore, if someone makes a change to them and it breaks the build, obviously you'll see that because you can just put CI on these things. So we think this is a significant improvement on using any technology that uses, magic templates that you can't use normal tooling on. As you can imagine, the tricky thing about doing this is if we're using a normal project as a template, how do we know how to transform it without all those placeholders? The answer is that we believe that the ability to understand and manipulate code is incredibly important. So we've made a really big investment in parsing, in like Java and Kotlin and TypeScript and JavaScript, as well as other languages and things that are applicable to all languages. We've made a significant investment in parsing. So the way in which my generator is going to work is it's actually going to parse this. It's going to parse every Java file in this project. It's going to find the Spring Boot application class, and it's going to work out what package that's in. It's going to use that to refactor it and rename. You can't do this kind of stuff safely with regular expressions. If you try to do just search and replace, as soon as someone puts a comment in an entirely legal place or messes around with white space, potentially your automation is fragile. So what I'm going to do to demonstrate that I can use normal tooling is I'm going to use VS Code, and I'm going to make a change to this project. So this here has a Spring Boot REST service running in New York City by the Hudson River. Clearly the last demo I did was at 2:45. I'm going to edit that. So I'm going to say running for the okay, so save this, git status, okay, hit push. Okay, that has pushed, and now you can see that there's some activity from my automation client, because that received an event to say, hey, there was a push to this particular project. So now it's invoking some of my handling code. So the handling code is causing that thing to be built. So we believe with ChatOps that a really nice model is one channel, Slack channel, per service. This is pretty good because it means that there's a natural community of interest. People can join those channels, they can leave those channels, they can follow along. It's really pretty nice for figuring out what you care about. And one of the interesting things about our Slack integration is it's bi-directional. So there's a lot of things that will give you updates, say from GitHub or build tools or whatever, but there are a couple of problems. One is they tend to be very spammy, so you'll get like a great mess of visually inconsistent fire hose stuff that people will tune out from. And secondly, you generally don't have the ability to perform commands. Like generally it tells you stuff, but doesn't let you actually change stuff. We address that. So let's now create a project. So I'll go back and press the button to get this thing to submit. So as you can see, my automation client is doing something. Actually, all those log messages refer to it parsing the Java files and doing the transformational stuff. And now it's suggesting that I might want to create a chat channel for that project. So let's follow that as I recommended. Let's create a chat channel there. And let's also have a look at the new repository, just to see that there is in fact a new repository. If we look in the source, you'll see source, main, Java, com, mapper, mothers, zapper, controller. And also if you looked in the POM, you'll see that's been updated. Also, if we go back here, you'll see that there are what are called GitHub topics at the top of Spring Boot, Spring and Java. So basically, Atomus not only created it, but listened for an event that said this project had been created, and it actually looked inside the code to tag it with these topics. So even if I'd created that repository by hand, I still would have gotten all that additional behavior. This ability to add additional behavior is really important because we might want to perform, say, a security scan on every project that suddenly appears. So Atomus makes it trivial. For example, to just check the new project turns up, scan it, see whether or not it conforms to organizational standards, and if not, do something. You can see here that there's also a button up here suggesting that we add a Cloud Foundry manifest. We support deployment to Cloud Foundry and Kubernetes out of the box, but we really could support deployment to just about anything. So, for example, looking at Ray's demo, I was really thinking about how we could automate that, like adding the files so that you can look at a Spring Boot project and just make that GCP ready. We could definitely do that. So, how does Atomus know to add this Cloud Foundry manifest? Let's do what I've been wanting to do all evening, which is get to the code. So if we look in the Cloud Foundry support here, you'll see that we've got a configure function that's working with our SDM. SDM is short for Software Delivery Machine. And one of these listeners that we can register with an SDM is a channel link listener. So this meant that when a Slack channel was linked to a repo, this piece of code fired. So basically, this piece of code was executed. Most of the code in it is to do with Slack message formatting for putting on the button, but you can see here that we actually add a button that invokes an Atomus command. So essentially, when I press that button, it's going to go back to Atomus. Let's have a look at what it does. So we're going to do that. Press that button. Now you'll see Atomus do one of the things that it's very good at, which is modify code or configuration using a function that you wrote. So here the Atomus ChatOps integration will give me a handy link to the PR. Atomus by default will surface its edits as pull requests. You can also tell it to commit to master if you really want, or just commit to a branch without a PR. Here we have the files that are changed, and you can see that manifest has been created, but the really interesting thing is this: the manifest was parameterized with the name of the project. It actually did that by parsing the POM. It's to have this ability of editing projects either one at a time or at scale, you have to have a really sophisticated ability to parse code and configuration. Okay, so that looks pretty cool. Remember I said these things are bi-directional? Out of the box, Animus gives us the ability to drive GitHub or Bitbucket operations like merging. So here I merge it, and you'll see my automation client's going off, and it helpfully suggests I might want to delete the branch. This is a really important pattern where, sometimes you really want to cause people to make a decision, right? Like, it would be pretty rude to delete the branch automatically. Obviously, you could code that up if you wanted, but that would be pretty rude. It's better to let the person decide to do it. I absolutely hate having a proliferation of branches. I was so pleased when I looked at one of our main open source repos today and I saw there were precisely 2 branches in it. It made me strangely happy. There is nothing I hate more than having dozens of branches. Okay, so a couple of interesting things here. One is that you can see that more stuff happened this time. If we go up here, we saw that, thank you Slack, this gives me the opportunity to get some water. It's been actually doing that all day. So, if you look at these goals, originally we had 4 of them. Now we have more than 4. How did this happen? So goals are how Atomist handles delivery. So basically, it's like dynamically computing what you would often think of as a pipeline. Rather than having a fixed pipeline, you're able to dynamically compute it. So what are the inputs to computing it dynamically? They include things like, well, what kind of project is this, right? A push to a Spring project's different to a push to a Node project. They include things like, is this a push to the default branch or some other branch? Is there a build associated with any of these commits? Who made that push? All of these things are held in our core model and are exposed when you write listeners. So at this point I'm actually going to go and log into Atomist and show you what the data model looks like. Remember that I said we have a joined up model. Let's have a look at pushes. So here this is using GraphQL. We make our model available via GraphQL. So probably the most important thing in a push is commit, and so shower and message. So let's just have a look in my demo team at some of the commits we've got, and it shows us the shower and the message. But in fact, the Atomist service is sitting there when it receives a push, for example, from a webhook fired by, say, GitHub or Bitbucket. It actually correlates that with everything else it knows. And one of the magical things you can correlate on is the commit chart. That's an incredibly important thing. So let's have a look at some more information about this. Probably want to know what repo it was on. So the reason this is so important is because there's an obvious advantage in running the events through a single event hub rather than having 1,000 pipelines. But in order to be able to do that, you've got to be able to make decisions, right? You no longer are guaranteed the project context. So here it's showing us the repos that we made the commits to. Let's think, for example, about the committer. Who is the committer? What do we want to know about this person? So one of the things we might want to know is where this person lives in GitHub, since this is a GitHub team, and where they live in Slack. So usually, by the way, that was obviously a fairly expensive query, usually we work with subscriptions rather than explicit queries. So normally you're going to get in your automation client a subscription kick that says something like this occurred. Okay, let's now, understanding the model that Atomist has, let's try to figure out why we ended up with more stuff. And while we're at it, let's actually see what happened here. And yes, it actually deployed it. So notice this is the notion of organizational policy that I said was missing. So my organization knows how to create Spring Boot projects. Also knows how to create Node projects, and you can teach it to create other projects. It knows how to deploy Spring Boot projects that have a Cloud Foundry manifest, and you can teach it to deploy other projects. So it's this notion of an organizational policy which is, I think, really very powerful. So, still haven't explained why different things happen. So the most important single event that we process is a push. So here I'm configuring my software delivery machine to react to a push. We have in TypeScript an internal DSL that enables you to do this, and you can see, it's pretty readable. Like this says on every single push, you're going to do code review and what we call push reactions, which is like run an arbitrary function when this event occurs. If the project has Maven, is a Maven project or a Node project, build it. If the project has a Cloud Foundry manifest and it's a push to the default branch, go deploy it. Don't deploy all the other branches. But if something makes it to master, deploy it on staging and then production. So it's really easy to write these kind of predicates. So a lot of them depend on what's in the project. So for example, let's write a predicate that checks whether the project has a README. It's that useful, but so it will be is predicate push test. So has README. Basically, this will just take a function from the project to return a promise of whether or not we should do something with that. So let's say it's whether readme.md is truthy. So now we could use that anywhere we wanted. So has readme, we can just put that into our DSL. So, hopefully this starts to give you the sense that doing stuff in code is really pretty good. Like when you can code with stuff, you can do creative stuff really quickly. Similarly, if you want, you could make decisions based on the project name. So for example, if the name includes very special, you could do something different. So this is one of the key ideas of Atomist, this idea that you can change your delivery and automate all kinds of other things in code. So this SDM is what we think of as the Spring delivery, where it's pretty productive. Okay, what I'm going to do is prove this by shutting down my local software delivery machine and making some changes. So I'm going to add what we call a push reaction. This is a piece of code that will be invoked every time there's a push to any project. If I wanted to, I could narrow it down so it uses the DSL to only get into Node projects or Spring projects or whatever. But for the sake of this, I'm going to demonstrate it on everything. So what we'll do is check to see whether that project has a read. No, actually we'll check for the number of files in the project. So file count equals pu.project.total file count. Our API is a modern Node API, so it uses promises everywhere, promises and streams. You can use async await, which is really very nice. So what we'll do is, on all of these event listeners, we have a very convenient ability to actually respond in Slack or in the web interface or wherever we've got to go. So we can say project at, and we can get all the information from the project. So pu.id.url has, and its file count, total files, and while we're at it, we'll put in an emoji because people like emoji. We will also, to demonstrate this, that the listeners extend beyond push, we'll add a listener to anyone creating a new issue in our team. So, why don't we just say thank you, because we aspire to be nice people, we aspire to encourage our colleagues. So we'll do address channels. So remember I showed you how you can get to like related things like who this person is. So i.issue.open.by.person.slack.chatid.screen name. And we will say thank you for raising issue number, and we can get that from the issue. So, and this should have been I. Okay, so all we need to do is restart this, and we get that behavior across our entire team. Because it's running, now we have the notion of organizational policies. Okay, so the first thing I'm going to do is make a push to this project. Okay, so we're already up at, let's go here, and let's add a new file called, create a new file called city, New York City. Commit. Obviously now, as we know, we'll get an event. When it gets to the code review phase, you can see, or the push review, you can see that it counted the total files. What's more, I can go and do that in any one of these other projects. Like, for example, if I make a commit to, say, Montreal 2 that I did the other day, I could do, I'm just cheating here by using an Atomus command that will actually change a Java file at random for me. You can see that we'll get the same behavior, and it counted the files on that. So, imagine if, for example, you wanted to integrate something like SonarQube or Black Duck, or some custom check that you have in your own. You can do it across your entire organization. Very, very easy. Okay, let's let's do a couple of other things now to generate the value of doing this in code. One is, just because it's really fun, I'm going to add a bot command. So this is really trivial. So we'll call it hello intent. This is what you have to type in Slack to get it to work. And we also do a listener for that. So that is a complete bot command. That's kind of a little bit too easy. So let's make it a bit harder. We'll actually create parameters for that command. So it's funny, after seeing Ray type Java, I'm almost typing Java. So if I annotate this with @parameters, this is using a feature called TypeScript Decorators. They're really quite cool. Is that the right one? Is that the right one, Christian? It is, isn't it? Yep. Okay. So here it's somewhat spring-like. These parameters will be injected on this instance. So when it instantiates its parameters class, it will inject those. So now we can go back to where I did add commands, and we can say, so this time we'll parameterize it and use our parameters. We need to tell it how to create what parameters it needs, and we can actually just pass in the name of the class. That TypeScript gives you the ability to access even statics and constructors through an interface. And instead of hello New York City, why don't we say hello ci.parameters.name. Okay, so now we've got a new Slack command. Let's also demonstrate how Atomus can solve some of the problems that you saw around making code changes across multiple projects. I think you've seen with the push reaction how we can potentially make changes to how delivery occurs across multiple projects. We can also make code changes. So I'm going to write what we call an editor, and I'm imaginatively going to call this editor add thing, and to get it to work I will need to type in add thing, and what it will do is it will add a thing. So it really takes a function that just takes the project, and our project API is very simple. So this is going to create a file in the root directory called thing. If we wanted to be somewhere else, we could do that, and it will respect the directory paths. Like obviously in many cases you want to do the kind of thing I did with the Cloud Foundry manifest, and like do some parsing first to know exactly the nature of the thing you want to add. But you can easily write these functions that work against a project, and they work across as many projects as you want. Remember I said that we want to get the benefits of computer science and engineering. One of the benefits is testability, right? We don't deliver code to production without testability. Clearly we would like to test this. Given that I'm one of the architects of this API, and as is Christian, and we're both Spring people, you can expect that testability plays a big role here. So let me show you the code that added the Cloud Foundry manifest. So it ends up doing an interpolated string after it has parsed either the POM file or the package.json file. You know what? We can actually unit test this. So we can test it in memory. So I can just run add Cloud Foundry manifest, and it will execute quickly. And so it's already run those tests, never went to Git, never went to GitHub. Like Atomus can handle all that transparently, but it tests that it works. So for example, if I change this code here to deliberately break it, so say instead of putting in the application name, I put in something completely ridiculous. So let's, instead of the application name, I'll put XXXXX, rerun the tests. You should very quickly find that this is broken. So it says assertion should contain app name. So you have a very nice development experience here. So going back to my machine, this is going to add a file called thing, and this will be available across all my projects. Okay, let's restart it. We want our hello command, and we want add thing. Okay, so we'll go back to Zapper, though of course this will work anywhere. Atomist, hello. And we also do have a web interface, but frankly when it works, Slack is pretty great. Atomist, hello. Okay, what Atomist has done is started up the thread, and it's asked the name. If I wanted to, I could have put a description and like validation patterns and all that kind of good stuff. Okay, now it's going to submit it, and here we have So we were able to create a Slack command that had parameters incredibly easily. Okay, so now I have two more things, and then we'll be done. The first thing is we haven't added a thing. Adding a thing is clearly very important, so let's add our thing before Slack restarts. So, Atomist add thing. This is in the background, that log output, it's cloning the project, and it's going to add a thing and commit it back. It's idempotent, so if you already have a thing, you don't need to get another thing. And by default, it will surface it as a pull request. So if we look what we've got here, files changed, we've got a thing. And of course that kicked off a delivery flow. It is possible that adding a thing is not that useful, but certain things are really important. So you can see, for example, if you wanted, say across all those Google configuration files, if you wanted to change, like scaling settings or whatever, you can just blow that out. Write something, test it, blow it out across your organization. Now, the really important thing is to actually upgrade versions. Remember, Equifax, not very nice because they didn't keep their Slack up to date. We can take care of that. So, for example, Atomist try to upgrade Spring Boot. So what this will do is, it's an out-of-the-box command that works with Spring Boot Maven projects. It actually looks in the POM, and if it sees that it doesn't have the current version, it will make a neat little edit. It will then wait to see if the build succeeds or fails, because clearly if the build fails, it would be terrible to have a PR. It would be as minimum rude, but might actually mislead people. So here you can see that it eventually created a PR because it saw that that project still built on Spring Boot 2. So if we go back here, let's have a look at what was in the PR. We've got here the upgrade to 2.0.1. If I wanted to, I could run that across any number of projects. So let's run it across. Let's run it across the projects that I created today. So I can put in a regular expression. And now we should see my automation client get busy. And if we go to Slack, we should, if we watch those New York projects, we should see some activity coming in. You'll see one, obviously, just hit NYC4. So if you look at all of them, they've got pull requests. So that's actually a standard behavior, what we call a dry run editor. So it's actually in our core Spring support, but you can also use it for non-Spring related things. So hopefully that gives you an idea of why we think that delivery needs an equivalent of Spring, like J2EE needed Spring back in the day, and how if you think bigger in terms of let's have an API for everything that you want to do with your code or your delivery process, if you think bigger, you can actually produce a really nice joined up experience. So, I've been writing a ton of code. Lately, obviously, we have a great team. I'm just one of the engineers, but I have to say I've been having an absolute blast. And, this is, again, something I really believe that the industry needs. Thank you.